Now, adding and subtracting rational expressions will take a little bit more work on our part. Just like with adding or subtracting fractions, we need to make sure that we have a common denominator first. When we're dealing with rational expressions, it's a little bit more involved, but in some ways it can be a little bit easier. Our common denominator is often going to be some form of a product between the two denominators, given, for example, if they are b and d. And then we just need to make sure that we multiply the opposite equation by whichever of those factors it's missing on the top and the bottom so that we get the common denominator. So let's go ahead and just dive on in. So looking at the sum of these two expressions, well, they already have a common denominator, so we don't need to do any rewriting. We just look at x squared over x plus 3 plus 4x plus 3 over x plus 3. Since they have a common denominator, we can write the sum of the numerators over the common denominator. Notice how I only have x plus 3 once, because we're not adding the denominators together, we are just writing them as the common denominator. The denominator just represents the whole out of how many parts. Then when we're looking at our polynomial, we're going to see, can we factor and simplify it? So I have a trinomial in my numerator. This can indeed factor to be x plus 1, x plus 3. And then since our denominator is also x plus 3, we can simplify by eliminating the common factor, leaving us with the sum equals x plus 1. Now we'll do a difference. Same idea, we need a common denominator, but notice that our denominators do not match. And so I'm going to write this out really large just so that we get the idea, and hopefully as you become more proficient, it'll be a little bit easier to follow. So we have this expression. I added some large spaces in here for us to maneuver, but our common denominator is going to be the product of these two denominators, x plus 3 and x plus 1. Now the fraction on the left did not have the x plus 1, so whatever I multiply on the bottom, I need to multiply on the top. And on the right, we were missing x plus 3, so we'll multiply that on the top. Before we subtract, it's a good idea to go ahead and do distributive property within the fractions. So we'll have 2x squared plus 1 over, 2x squared plus 2x over x plus 3, x plus 1. We'll leave our denominator factored, minus 3x plus 9 over x plus 3, x plus 1. So now we have the matching denominators, so we can write it as one big fraction over the common denominator. So we have 2x squared minus 2x minus 3x plus 6. Now, just like with our polynomials, when we are subtracting, we need to remember that both terms will end up being subtracted in the numerator. So this becomes 2x squared minus 2x minus 3x minus 9 over x plus 3, x plus 1. We'll look at our like terms, and we'll combine those. 2x squared minus 5x minus 9 over x plus 3, x plus 1. Then again, we want to see if we can factor and simplify. Well, if we try to factor, there's no product of negative 18 that gives us a sum of negative 5. So this quadratic is not factorable, meaning this as simplified as we're going to get. We'll go ahead and do one last one. We want a sum of these two expressions. We have 3 over x plus, I'm actually going to add in some room here, plus x over 2x minus 3. So our common denominator is going to be the product of these two, since they don't have any common factors. So 2x minus 3 gets included in the left fraction, and x gets included in the right fraction. So we'll go ahead and distribute within our numerators. 6x minus 9 plus x squared over x 2x minus 3. Rewrite it in standard form. X squared plus 6x minus 9 over x 2x minus 3. And we try to see if we can factor. There's no factors of -9 that add to +6, so we can't factor it. So that's as simplified as we can get.